How many of you have seen the movie Glass Onion? Okay, a good amount of people, but not everyone. So I will briefly summarize for those of you who haven't seen it. So Ed Norton plays a billionaire tech entrepreneur who's about to launch a new climate-friendly hydrogen fuel that he claims will be powering the dreams of Americans by the end of the year. There's also a murder mystery plot, and this part of the movie is pure Hollywood imagination. But hydrogen as a fuel of the future is far from fiction. As many of you probably know, there's a lot of real excitement about hydrogen, with governments and companies rapidly advancing plans across the world to replace fossil fuels with hydrogen. And now some unsolicited advice is to not set a Google alert for the word hydrogen, because you will literally get this many articles sent to you every hour. And that's because everyone is talking about hydrogen. Now, this isn't the first time that there's been excitement about hydrogen. Every time we've had an energy crisis in the past several decades, there has been excitement for hydrogen as a potential solution. But a hydrogen economy never happened, mostly because it could never compete with much cheaper fossil fuels. But today we have a crisis unlike anything we have ever known, and the entire world desperately and urgently needs to get off fossil fuels. So interest in hydrogen has never been greater. And that is because hydrogen is considered an abundant, carbon-free, and versatile form of energy. And that is exactly what we need to combat the climate crisis. Now, when I say abundant, I mean hydrogen is everywhere, in plants, in animals, in us, in water. When I say hydrogen is carbon-free, I mean that in the form we use it, as two hydrogen atoms bonded together, there's no carbon. So we don't release carbon dioxide when we use it. And when I say versatile, I mean that we can use hydrogen for so many different purposes. As a fuel, we can either burn it or convert it directly into electricity. As a specialty chemical, we can use it to refine fuels, and make other chemicals that are used in hundreds and hundreds of products. And we can also store energy in hydrogen so that that energy can be used at a different time or at a different place. And it's this versatility of hydrogen that enables it to help solve some of our most pressing decarbonization challenges. But at the same time that there's all this excitement for hydrogen, there is a growing body of research that suggests that for a climate solution, hydrogen actually has a number of climate challenges that threaten its success. And whether or not hydrogen helps or even harms the climate depends entirely on how we make it, how we manage it, and how we use it. So today I want to walk you through what the latest science says about some of these climate risks of hydrogen. And I want to talk you also through how we can minimize some of these challenges so that we can realize the rewards of hydrogen. I've spent the past 2 years at Environmental Defense Fund leading our scientific research on all the unintended consequences of hydrogen systems. And as a scientist who really focuses on these issues, my concern is that they are not well known among stakeholders, and they are not taken into account in current projects to the extent warranted. So I am here today because I want to get hydrogen right. Hydrogen has major potential to help us solve our decarbonization issues and also just help us decarbonize society. But the reality is that for every one of these promising attributes of hydrogen, there are climate risks that threaten its climate benefits. For example, while hydrogen is technically abundant, it is really inconvenient. And this is because hydrogen on Earth is almost always tied up in larger molecules. It's very reactive. And so hydrogen needs to be made. And so this requires a feedstock molecule to get your hydrogen from, and it also requires a lot of energy. So this is hydrogen's first major climate risk. Now, the most viable climate-friendly option we have today to make hydrogen is using renewable electricity with water, and we call this green hydrogen. Today, we make around 35,000 tons of hydrogen using this method. But as we scale up hydrogen systems and potentially make 10 times more hydrogen than we even produce today over the next several decades, well, then it's going to require more and more renewables. And unless we have excess renewable capacity, which we are pretty far away from now, then the risk here is that we will be taking away renewable electricity directly from decarbonizing the power grid. Now, another way to make hydrogen that many still consider climate-friendly is by still using fossil fuels, but you capture the CO2 emissions. And we produce around 20 times more hydrogen using this method, which is called blue hydrogen, than we do green hydrogen. But the risk here is that natural gas is mostly methane, and methane is a powerful climate pollutant responsible for around 30% of today's warming. And natural gas can escape from all aspects of the supply chain. And so one of the major risks with still using this method to produce hydrogen is that we can still have a lot of methane emissions into the atmosphere. And because carbon capture technologies aren't perfect, we still have residual CO2 emissions as well. Now, the unfortunate reality is that 99% of the hydrogen we produce today is still from fossil fuels without capturing any of the CO2 emissions. So this emits a lot of methane. It also emits a lot of other air pollutants, and it emits a lot of CO2 into the atmosphere. So much CO2 that if hydrogen was a country, it would rank the 6th largest CO2 emitter. So hydrogen may not be carbon-free depending on how we make it, but regardless of how we make hydrogen, it actually isn't climate neutral. And this is because when the hydrogen escapes into the atmosphere, it can actually warm the climate. And hydrogen is hard to manage. So this is the second major climate risk. So hydrogen is the tiniest molecule in existence. You actually could fit 500,000 hydrogen molecules side by side in the width of a strand of human hair. So you can imagine that it can easily leak from all sorts of infrastructure. And when it does, it traps heat in the climate. So this risks hydrogen's status as a carbon-neutral alternative to fossil fuels. Now, hydrogen is not like carbon dioxide in terms of how it traps heat. It itself is not trapping heat as a molecule, but it reacts with other molecules in the atmosphere that lead to all sorts of different chemical reactions and other physical processes that end up increasing the amounts of other greenhouse gases in the atmosphere. And all of these influences on the climate that hydrogen has last for around a couple of decades, but while they're occurring, it's very powerful. The latest science suggests that hydrogen has 40 times the warming power of CO2 over a 20-year period. Now, how serious of an issue this is depends entirely on how much hydrogen we emit into the atmosphere. And the problem here is that we actually have no idea how much hydrogen is emitted, not just today, but especially in the future when hydrogen systems may be a lot larger and more widespread than they are today. So it's been reported that hydrogen can leak from every component of the value chain. And routine operations even intentionally purge and vent hydrogen into the atmosphere. But no one has ever measured how much hydrogen is being emitted. And this is because we're only monitoring hydrogen emissions from a safety perspective, where we look at large leaks that could potentially be explosive. So it turns out that today's sensor technology isn't even capable of measuring small leaks that matter for the climate. Experts think that anywhere between 1 and 20% of hydrogen may be lost to the atmosphere. This is a really big range. So the question is, what does this actually mean for the climate? Well, my colleague and I published a study last year where we looked at a set of fossil fuel systems, mostly in transportation and industry, and we replaced them with green hydrogen alternatives. And then we calculated the warming impacts from both of these systems over a 100-year period. Now, what we found is that if we are able to keep hydrogen emissions to a minimum, say around 1%, then we could virtually eliminate the climate impacts from the fossil fuel systems in the long term. Now, if hydrogen emissions are at the higher end, say around 10%, well, then the climate risk here is that it is far from climate neutral. We still have a lot of climate benefits to swapping out fossil fuels for hydrogen, but it's nowhere near the climate neutrality that people think it could potentially be. And as I mentioned in a couple slides ago, hydrogen has most of its warming influence in the near term. So if instead of looking at the next 100 years, we look at just the following 20 years, well then hydrogen has even less climate benefits if we have high emissions of hydrogen. Now this is just for green hydrogen, where the only influence on the climate here from the hydrogen systems is coming from the hydrogen emissions. But what if we have blue hydrogen, where we're not only emitting hydrogen, but we're also emitting methane? Well, in this case, if we have high emissions of both methane and hydrogen in the near term, we could end up in a situation where we're actually warming the climate more than we would have been with the fossil fuel systems. Now, the final risk here is that hydrogen may be versatile, but it is not a universal solution. And this is because hydrogen may not be the best option for the job. And so this is the third climate risk. Now, I've heard many people refer to hydrogen as the Swiss Army knife of the global economy, able to pretty much do any job that needs doing. But just like I would not use my Swiss Army knife to carve my Thanksgiving turkey, and you probably wouldn't either, hydrogen may not be the right tool for the job. In many cases, we have cleaner, cheaper, and more efficient alternatives. For example, while we could use renewable electricity to split water molecules to get hydrogen and then pump that hydrogen into homes to heat them, we could also just directly use that renewable electricity to heat those homes. And if we do, we could potentially heat up to 16 times more homes using that electricity directly. And so the risk here is that we could potentially delay our clean energy goals because it requires so much more energy to do the same task. So hydrogen is abundant but not convenient, and it's carbon-free but not climate neutral, and it's versatile but it's not a universal solution. So hydrogen may not be a silver bullet, but at the same time, it also isn't a non-starter. Hydrogen is an opportunity that needs our focus now. Because while there may be many climate risks to hydrogen systems, the ultimate reward, if we get it right, is that we can achieve our climate goals. So the question is, how do we get from where we are today to where we want to be? And so my colleagues and I have been working with industry leaders and governments and engineers and professors and you name it from across the entire world to determine how to get hydrogen right and how to effectively make, manage, and use it. And we've come up with a number of different actions that can be taken so that we can ensure that hydrogen lives up to its potential. It is a very, very, very long list, so I will spare you that, and I will just try to briefly summarize what the key points are. So first, when we make hydrogen, it needs to be clean and complementary to other clean energy goals. For example, we need to decarbonize existing hydrogen production, which is a very dirty process. We also need to set a really high bar for if we're going to use fossil fuels to make hydrogen. And if we're going to use renewables, we need to make sure it's additional renewable capacity beyond what's needed to decarbonize the grid. When we manage hydrogen, we need to make sure that our systems are as tight and strategic as possible so that we're really minimizing opportunities for hydrogen to escape into the atmosphere. This will require some new technology to detect and monitor small hydrogen leaks, which we are actively working on right now. And then we can mitigate the emissions once we know where they're coming from, while also identifying best practices and deploying those as we scale up hydrogen systems. And finally, we need to be really appropriate and intentional with how we use hydrogen. We need to prioritize systems where we use hydrogen already today, for example, making fertilizer, and also systems that can't be easily electrified, like in heavy industry and long-haul transport. The great news is that the hydrogen industry is in its infancy. So we have an opportunity right now to ensure that the enormous investment in hydrogen projects worldwide can deliver on their promise to protect the climate. And we can get ahead of these challenges before hydrogen is scaled up and infrastructure is built out. Because what we do today will determine where the hydrogen industry will be in the future. And so my hope is that we can all come together to act on this information. And if we do, we can get hydrogen right. Thank you.